I'm interested in doing projects which are outputs. And I incorporate in my process a number of ideas and discussion, but all of them has to be intended to the extent that they need to deliver a design outcome in the end. The notion of creativity which I heard in these 2 days, which attracted me the most, is that of creativity as a drive. To my understanding, that's the purest way of intending it. And in a way, it relates to what may be the first idea of creativity that any creative person had in her or his life. If you go back in time to when you were young, the first time you sketched something or wrote something on a piece of paper, that was in a way kind of a pure act. That was coming out of something that you don't know. That's a drive, no? It's something you don't know. You just do something because you feel like doing something. And I think that in time, this type of approach has to be refined and find a way to negotiate itself in the world and grow and transform and change. But I think that preserving somehow the purity of that drive is something very relevant. So the presentation we're going to see today has a first part in which I will try to define a bit more in detail a certain key element of my design research agenda. And it's oriented in 3 main streams in which I will show how 3 projects born out of a pure drive then became negotiated into something else. It's a design research agenda, which means the aim is to do projects that are provocative and that challenge and open and aim at creating radically different scenarios. So I think it has to be evaluated in that mindset, first of all. I define my design research agenda as postnatural design, and for me, postnatural is an operational definition which I give, and it's operational in the fact that it's a tool that I use to explore scenarios, to explore ideas, to explore options. I define postnatural as an ambiguity between natural and artificial, human and inhuman, and cultural and natural, and so on. Things that we've been discussing this day. I'm interested in blurring these boundaries and exploring the condition that comes from this merge. It's not a definition which I created. I think it's something deeply rooted in our culture, at least since 30 or 40 years. At the philosophical level, we've been discussing that. Just to quote one author among the others, Steven Shaviro in Discognition, we can no longer think of nature as one side of a binary opposition. In an age of anthropogenic global warming and genetically modified organisms, not to mention big data and world-encompassing computing and communication networks, it makes no sense to oppose nature to culture, or a state of nature to human society, or the natural to the artificial. Human beings and their productions are not separate from nature. They are just as much, or as little, natural as everything else. Don't know if you know the work of this photographer, Edward Burtynsky, engaged in a major project called the Anthropocene project. Does anybody know what is the Anthropocene as a definition? It's a definition that is a scientific definition to indicate the geological era in which we live, which is defined by the fact that the human activities are shaping the Earth to an extent that is not precedented. So actually the fact that the human species is thriving onto planet Earth is actually shaping and modifying the Earth itself. And the work of Edward Burtynsky is to go and document these changes. So this that may look like a subterranean tunnel is a picture shot in Detroit, and this is actually a cut into a stack of paint, car paint. So car paint was placed as disposed into a pool, and then cutting through, you get this layering. And this is something that if you look at it, if you know what I'm discussing, then we can trace it back to something artificial, but at the same time, the look is entirely natural. And that's already an element of ambiguity. Same for pollution. This is our rivers of pollution, don't know exactly which one, but the type of shapes and patterns that emerge look deeply natural. So we know that by the time in which we start looking at Earth and see these types of shapes and morphology already, what is natural and what is artificial visually and aesthetically becomes extremely ambiguous. And it's a territory which is complex to explore. It's not only about how we do things, but also how we look at things. So I think there have been a few revolutions in the way we look at the world that are radically changing our perception. I'm referring here to satellite images. The image on the right is a satellite image of the city, while the image on the left is a microscope image of slime mold. Slime mold is a type of mold that grows and creates these networks. And if we compare the two images, you start seeing that, okay, one is a city, so it should be artificial. The other one is a living creature, should be natural. They start to look very similar. Maybe if I didn't know that one was one and the other was the other, then things would become difficult to distinguish. So what I argue here is that the scale at which you look at things is already changing, and the fact that we are accessing different scales to look at things is changing our way of perceiving. Same thing. Pine berries and tulip and rainbow tulips. Genetic engineering is creating new species. Look like a strawberry, like a white strawberry, tasted like something in between, I guess. I never tried. But I think that, is it natural? Is it artificial? Is it cultural? Is it original from the planet Earth? What is this? Software. This is an image from Krakatoa, which is a particle simulation software. It allows, as you start working with complex simulation with millions of particles, you get these shapes, which look radically very natural to our common understanding, but in fact they are completely digital. So digital technologies are actually creating a kind of hypernature in a way. Maybe such type of brightness in color is not actually something that you can find in nature, but is actually augmenting our sense of nature. One of the three is virtual. The other two are real. Which one is the virtual one? Let's raise hands. Who thinks that the first on the left is the virtual one? Raise the hand. So let's spot the virtual one. So who thinks the virtual one is the one on the left? Who thinks the virtual one is the one in the middle? Who thinks the virtual one is the one on the right? It's the one in the middle. Completely digital. So imagine that we're used to think that the virtual is something that happens in the computer, in a digital space, and the physical is something that happens in reality, but these type of notions are actually becoming way more and more blurred. So maybe this distinction between physical and virtual is also something that we should reconsider. Quoting Donna Haraway, I want to signal three crucial boundary breakdowns. By the late 20th century, it's a text is named the Cyborg Manifesto. It's from the 1985, if I remember well, but I think it's still very there. Maybe not for the philosophical discourse, but for a design discourse is very present, I think. By the late 20th century, the boundary between human and animal is thoroughly breached. The last beachheads of uniqueness have been polluted, if not turned into amusement parks. Language, tool use, social behavior, mental events, nothing really convincingly settles the separation of human and animal. The second leaky distinction is between animal-human organisms and machine. Late 20th century machines have made thoroughly ambiguous the difference between nature and artificial, mind and body, self-developing and externally designed, and many other distinctions that used to apply to organisms and machine. Our machines are disturbingly lively, and we ourselves frighteningly inert. The third distinction is a subset of the second. The boundary between physical and non-physical is very imprecise for us. And we get into design. I do a few things in my life at present. I teach the Bartlett School of Architecture. We will see something later in London. In 2012, I co-founded MOX, which is an independent design research group. We started as a EU-funded group to work on 3D printed product and customization onto the human body. And we're going to see most of the project from that. And then we worked for 3 years with a very specific focus on that type of products. And then we started doing also other different type of things. And on top of that, I work at Zaha Hadid Design as a product designer. The work that we do at MOX is mostly experimental in this sense. So when we started working with the idea of object that customized on the body, the idea of the cyborg came quite directly into our imagination, and we started exploring it at many levels. Another fundamental reference for us was the book Natural Born Cyborgs from Andy Clark. My body is an electronic virgin. I incorporate no silicon chips, no retinal or cochlear implants, no pacemaker. I don't even wear glasses, though I do wear clothes, but I'm slowly becoming more and more a cyborg. So are you. For we shall be cyborgs, not in the merely superficial sense of combining flesh and wires, but in the more profound sense of being human technology symbionts. Thinking and reasoning systems whose mind and cells are spread across biological brain and non-biological circuitry. May sound complex. The main thesis in the book is in a way the fact that any technology that we use is not something external from us, but is actually becoming a tool that is actively changing the architecture of our mind. If you think of the expression thinking through writing, or the fact that you think that you might focus ideas while writing, what is being argued in the book is not that the pen and paper technology is an external thing that is just helping you to put something that you have in your mind outside, but is actually a tool that is changing your mind. So the technology becomes a part of your mind. It's just another tool. And that way it expands what you are. So the notion of self, which is very strong in our popular culture, is actually being discussed. And is discussed more and more how you enter complex relationships with other entities, which can be other people, social group, but what I'm mostly interested in here for the design perspective is technology. So the work that we're doing is orienting and understanding at some level, mainly aesthetical levels, how the relationship between human and technology can be redefined in a single symbiotic entity. The first project in which we explore this is a set of masks. And there's a video coming. There should be an audio. Okay. The year is 2013, boom of 3D printing, hype of 3D printing, and the core of the project is the technology that we put together of 3D scanning the human body, having a set of digital tools that allow you to create in a customized way the morphologies of the mask, and then outputting files ready for 3D printing. The algorithm behind the morphology, we're talking about generative design. Everything was coded in processing, and takes as input a set of cures, and then generates a population of random one that follow the same directions, rearranges them according to a bundling algorithm, which is basically clustering their control points together, and solidifying them in a single mesh, ready for 3D printing. So our research on this type of morphologies is post-natural in the sense that we are interested in morphologies that look natural or retain some element that take us back to that kind of imagination, while at the same time being entirely digitally developed. And the thing that everything goes through a software means that the process is automated. So if you think of manually modeling in any 3D modeling software such as Maya or that type of stuff, it would take at least 1 day to model each of them, while in this way we were able to put each one of them, to output each one of these morphologies every few minutes, if not less. The design process is evolutionary in the sense we were discussing before, so what you do is generating a very wide pool of variations and then selecting the ones that go through and possibly iterating the process throughout. So to select this 20 was a project of fashion accessories in which the brief was about having every piece different but belonging to the same language. And in order to select these 20 pieces, we generated something like 1,000. So the problem then becomes how you select them, because that's another level of the process. The masks, I see these images as what we can call postnatural cyborgs, in the sense that they are entities in which they are symbionts of a human element and the technological one, at least at an aesthetic level. And they are postnatural in the sense that it's not clear where's the boundary between things. Is it natural? Is it artificial? Is it technological? Is it cultural? Is it human? Is it inhuman? To a certain extent. So it's a speculative artifact in terms that it's meant to create or to generate conversations and to think in this direction. We are interested not really in doing something which is, sure, it's digital, it's not something that is grown, but what is interesting for us is having an object that supports the speculation onto a design research agenda. This project came out of a drive, as I was saying before. It was not coming out of a brief. We knew that we could do something like that. We were excited to try to experiment in this direction, and we did it. We were 3 designers, and each one of us designed a different mask that is showing a different relationship between the morphology and the human face. Then we come to the negotiation. When you do such a project and you deliver a strong image, the interesting thing is that, sure, it's ambiguous, sure, it's not a product, sure, we didn't get any money out of that, if not the one of the research grant. Sure, all of that, but this object triggers conversations. So it was something new, it was something different, it was widely published, and it kicked off a number of conversations. So we started talking, very different people were seeing different things into this object. So some people were attracted by the potential for fashion, let's do fashion accessories. Other people saw the customization as the most relevant thing, so let's do medical products, and so on. So we were engaged for a lot of time in negotiating all these type of things and see how this project may generate other things. One of the most important projects that was bred by these collagen masks is a project, is a stream of project dealing with medical products. So the idea was to work with prosthesis and how we can design a prosthesis through 3D printing and technology of 3D scanning. So the idea here was, again, an aesthetical exploration onto the leg prosthesis, how this can retain something human, like the proportions of the legs or the shape of the leg, but at the same time incorporating elements of variation, such as the fact that the joints are open and then the leg is not continuous and the object doesn't want to look like the natural leg, but as something else. And if this project was at the same time still speculative, it created another project which was more applied, which is a set of orthoses. And an orthosis is a device which is basically meant to stabilize a limb or like prevent it from moving. And so the idea is that if you can 3D scan a hand or a leg or an arm, then you can have a device which is customized and is more comfortable and works better with the patient. So it's personalized. And at the same time, since it's 3D printing, we can work with complex geometries like these holes. And then the holes may have a role in that as well. So air can go through. Generally, these type of devices are continuous and without holes. So it gets very sweaty inside, while this way air can go through. You can wash the device and the hand while wearing the two of them. And then you can also work with the performance of the object in a more complex way. So the pattern is controlled digitally. It changes the size of the holes in different parts. Where the holes are smaller, the object is less flexible. Where the holes are bigger and larger, then the object becomes more flexible. So you can incorporate also an element of control flexibility into the object, which you wouldn't otherwise have. And the leg orthosis. In this case, the research was how we can incorporate the leg orthosis and the plantar and then have something that generally these type of devices are completely stiff, so they don't move, they don't bend. But according to the doctors we were working with, it would be good if the object has a kind of flexibility in this direction, but not in that direction. So what we had to prevent was the rotation in this direction, while we could keep a certain range of rotation in this one. And then through the design of the joint along the ankle, then we were able to control how much the device was able to bend. Up to a certain extent it bends, after that the resistance is too much. These projects are currently still being developed. We're working with few clinics in Italy to try to have certain case studies. They are generally long-term projects. So we're moving from very blue sky speculation to something more applied. So in this case, this project proved the limitation of 3D printing, which is the fact that at the moment it's still too expensive for the market. But still, it's something that forecasts are showing may change in the next 10 years. So I think that it is also interesting as an exploration that you can have different degrees of permeation of reality with your speculation. While now we go to another blue sky speculation, still along the light. It's about an augmentation of the sight sense. So there is an idea which you can find following some of the fiction of the cyborg and the speculations which are related, which is the fact that the human body is something that maybe is not that functional as we're used to think it is. And maybe you know about bioprinting and the current advances in prosthesis, the infamous story of Jaco Pistorius, the Blade Runner, the runner which was working with 2 prosthetic legs, which were allowing him, before he killed his wife, to run faster than a natural-born runner. And that was for us a very inspirational story that makes us think that maybe we used to think of the human body of this great, fantastic, perfect tool, but maybe in fact it's not. And regardless of the fact that I may personally want to change a part of myself, it may be that at a certain point in time, people will start thinking of the body as a tool, as the body as a product, which can be enhanced and transformed and changed. So again, I'm not interested myself in really saying this is the future, this is going to be like that, everybody will cut off its arms and do something else, but I'm more interested in opening up the scenario. I think that much of the work I do is really this crafting of scenarios, in which then things can be discussed. And then it's a work in this sense way closer to fiction than to the design of products. The fiction in this case is concerning the eye. So how we can upgrade the eye. Let's imagine that in the future we have a technology through which bioprinting got so developed and so precise and so good that we can actually enhance the eye and upgrade it. And the eye itself becomes a product. So we were thinking, let's design this product in detail. So the product may have a packaging, but the product may also be a product range with different functionalities. So imagine that there are 3 models of eye: eye heal, eye enhance, and eye advance. The eye heal is basically restoring the functionalities of the natural eye, something very similar to what we have, while the 2 other models are introducing more and more functionalities. So eye enhance is basically enhancing our vision, making us able to see 50% better than we do. And eye advance is introducing other features, like the ability of directly streaming what we're seeing to a digital space, to the cyberspace, to internet and social media and so on. So in a way, something pretty similar to what later became then the speculation of Black Mirror and so on. So we came down to the fact of designing the anatomy of the new eye. And I think that that's a thing which is very interesting to me, that I like when I do this type of speculation to get into the details of the fiction. So to really design the product in detail, how it may be, how it may look. And I think that is a very important part of shaping the vision of the product. So lots of speculation, lots of blue sky. Yes?
Can I ask you a question?
Sure.
This is something that I think of it as a sort of a divisive question. That I've asked my friends many times, is that if you could have a cybernetic eye installed that would be as good as your current eye, but without any possibility of regeneration or anything like this, would you do it?
Myself?
Yes.
I would not.
You would not?
I would not.
How much better do you think it should be?
It may be. I think I have a very conservative philosophy of my own body. So I never did tattoos. I never experimented too much. I'm interested in the scenarios. I think I know people that would definitely do it, but myself I would not. And that's because I have, in this moment of my life, and it may change, a pretty conservative approach to my own body. It's not different from breast surgery, for instance. It's the same principle. Contact lenses and other type of changes. Also, the tattoo can be seen as a similar thing. It's just a way to enhance and change your body. It just looks radical because the level of change to what we perceive now is very high and very extreme. But as Jamshid was saying yesterday, of the speed of technology, that's very relative.
But it's also with the pacemaker, no?
Yeah.
Dialysis. And then there's a lot of machines and sensors, something that you're putting inside your body, and it's starting to look like something normal. And little by little, I think this would be normal.
I would be more interested in changing the eye if there was a product, and that may be actually a good idea for another project, a product that would allow you to see in a radically different way. Not in a better way, but in a different way.
Like if I could see ultraviolet and infrared, and if I could see, Wi-Fi, it would be possible. Yes, definitely.
But it's a different thing to replace something if you have to, like if you have an illness, but something that if you want to change. So I wouldn't, if I could take a prosthetic for medical reasons, I would of course, but if I could just change it because I want, I would not, because then I would take responsibility of my own body in an awkward way, because it would be shaped by me, so I would be comfortable with that idea.
That's another point. There's another point if the body becomes a product, it means there is someone designing it and someone selling it. So that's a political level also that comes into play.
The components of the human body are not more than $100. The value of a body as material.
Raw material.
Yes, raw material is not more than 100 euros. It's interesting because we are thinking about the body as a product, no? So what's the value of a body?
Yeah, but that can be challenged. Sure, the material, but then the material is formed, is organized. So replacing the same level of organization would cost money. And we actually don't have the technology at present to replace the full morphology and the way the material is organized.
How far are we from this?
I have no clue. I mean, it depends. Like, if you want a specific date, we will have it in 20 years or so. I have no idea, for real. I think that the idea of the thing is here, and then, I mean, it's not only this project, but it's really a trend in contemporary thinking. If you really look at like these Blade Runners, people running with prosthetic legs, or like also there are a new wave of fashion models or performing artists, which are amputee people that are doing performance with prosthetics. That's something which is here. So I think that then if the idea is here, then the technology will come faster than we may think. I think, anyway, going back to your discourse, that's quite interesting. It relates to another contemporary thing, which is about cognitive drugs, for instance. So sure, because there is another thing. So if I can have an eye, I can replace a natural eye with one that looks better, then how about, for example, the consequences on work of that thing? So like if I'm working within a team of 10 people, and we assume that the basic level is that we are all natural, if one guy has an upgraded part of his body, can work better, then can have an advantage in work, which is something that maybe is not fair. But this is something which we are already dealing with, like the cognitive drugs. So people which are taking Ritalin and all this stuff to improve the attention, that's a drug. Then is that a doping? Is that something that needs regulation? Is it something that brings an unfair competition into the workplace? So I think that I'm interested because this type of discussion which come out of a product that may look very blue sky, in fact are very contemporary. You can interrupt me, didn't say at the beginning anytime, and I'm more happier to go into this kind of discussion than to go on. Moving on. Blue sky stuff, but also applied things. So it came the chance after I joined Zaha Hadid Architects. I actually work at Zaha Hadid Design, which is the product team. It's a separated company actually within the group, and we work on product design. We have a product range that we sell directly of objects which are like sculptural objects, like centerpieces, vases, and all these type of things, which are sold like Alessi products. We can think of a competitive brand. But we also do collaborations. And in the collaborations, we go through a number of different things. And I think in this collaboration specifically, which is about sportswear, was the chance of bringing something of all this speculative research into a real product. So as we said at the beginning, we've been working with body scanning, ways to customize the object onto the body, and then an advanced manufacturing technique. In this case, we've been working with body mapping, a technique to map like the sweating areas, the differences in which the body sweats or gets heated up or cools down through sport activity. And then we designed the bodysuit, in this case, to have this pattern changing in type according to different areas. And then everything was manufactured through automated knitting. So the basic idea is that there is a body mapping, and there is a pattern. So the pattern into the garments, in this case, is basically controlling how two different threads come together. One is a cooling thread, the other one is a warming thread. And then by changing the densities, you can have a differentiated performance in different parts of the body. So if you look at details of the pattern, like there are the two threads being intertwined, and then this way was possible to have like cooling areas like under the armpit or the side, and have other areas which are actually warmer. And this is a product that comes out for 100 quids each piece. So in a way, through a number of things, what I want to show here is that you may start with a very speculative project, incorporate certain elements of research into that, and end up with a product which is ready and sold onto the market. And actually, now just to show off everything, this product doubled the sales expectations in the end. It was something new, there was a good storytelling, and there were the right conditions that in many other situations were not. But in a way, it proves that you can start from something out of a pure creative drive, and then this can become negotiated at a certain point with a more, in a business perspective. We're still working with them, and then these are other products. So the bra and the leggings in this case still have this pattern, which has a perforation. It's a warp knit technique, so it's knitting. The holes are not cut. It's actually that you leave a few stitches without connecting them, so the holes actually open up. And still the idea is to relate everything to body mapping in terms to enhance the performance of the garment. What will the future look like? Whenever a hotel, motorcycle, dress, trash can, or just about anything else is described as futuristic, it is usually because it is designed in a style that harks back to the 1960s space race. There is another visual stereotype of the future, the dystopian spectacle of chaos and decrepitude portrayed in Andrei Tarkovsky's 1972 sci-fi film Solaris, and the succession of Schlocker movies. But in design terms, this aesthetic is more accurately described as beaten up than futuristic. By contrast, the smooth curves, glossy plastics, and bold splashes of colors in the sets of Stanley Kubrick's 1968 movie 2001: A Space Odyssey and the TV series The Jetsons have dominated our visual perception of the future for over half a century. Not for much longer. We are now assembling a very different vision of the objects and spaces we will use in the years to come. A stream of technological advances, from increasingly sophisticated sensors to developments in 3D printing and other digital production processes, suggest that, as the French poet Paul Valéry put it in 1937, the future is not what it used to be, at least not when it comes to design. So this quote from Alice Rawsthorne I always found quite fascinating because there is this idea of the future, which is a model in the present. So in the present, we have a model of the future. And as designers, we can actually craft different models and affect the way in which the future will actually be. So in a way, the future is a product of the present or of the past, and that is something that we can discuss. As the article is pointing out, we are still, I guess, dominated by this idea of shiny surfaces, continuity of the 60s, but there are elements of changing. And I'm interested in trying to understand how different aesthetics may potentially create radically different perspective into that. In this direction goes the Carapace project. The Carapace project is a project, again, we go back to the creative drive at the very purity of that. I haven't mentioned it, a very important person is Alessandro Zomparelli, is the guy I work with in all this speculative project. We started together, and we both have a fascination for crustaceans and crabs and all this type of creatures. I find them quite beautiful and funny at the same time, so in a very intuitive way I'm attracted by them. And if you look closely at them, they have several layers which can be interesting to explore from a design perspective. And one layer is that if you look at the carapace, the carapax, which is actually the shell which is covering the main part of the body, if you look at the microstructure of it, you find out this type of porous structures. So this porosity is a way in which there is a reduction of material, and that makes the shell lighter, but at the same time quite resistant. So we were fascinated by that, and following that fascination, we started working with the generative algorithms and find a way to simulate the process of formation of this morphology. So the idea is that you have a population of digital agents, they move in space, and find certain ways to be distributed evenly onto a surface. And then out of this distribution of agents, then a morphology is generated. So we have this this pattern which is defined by this porosity, and then we were able to control the densities in different parts. So there are areas which are more dense, more stiff, less permeable, and areas which are more transparent and lighter. And we decided to design, first of all, a set of masks. So the idea is that the masks here are dealing with the body, again, and then the idea is that how we can imagine, like, okay, human body is defined by the fact that we have the bones inside, while crustaceans have the bones outside. So what if we start seeing how the human body can be transformed along this very intuitive and imaginational way of thinking. So we worked on the head, seeing how different type of shells may change different parts. The idea was to relate the morphology to specific senses, like this mask is working with the sight. Another one we will see later is working more with the hearing. And the idea for us was always to try to craft this image in which is showing a different relationship between the object and the body. Again, when we look at them, I think of a symbiosis between human and technology in its visual part. So how the human body can be transformed by these morphologies, and how we can create a symbiotic entity which is different from the human body itself. Back to the book I quoted at the beginning, Natural Born Cyborgs. Such technologies, once up and running in the various appliances and institutions that surround us, do far more than merely allow for the external storage and transmission of ideas. They constitute, I want to say, a cascade of mindware upgrades, cognitive upheavals in which the effective architecture of the human mind is altered and transformed. The human mind, if it is to be the physical organ of human reason, simply cannot be seen as bound and restricted by the biological skin bag. In fact, it has never been thus restricted and bound, at least not since the first meaningful words were uttered on some ancestral plane. For what is special about human brains, and what best explains the distinctive features of human intelligence, is precisely their ability to enter into deep and complex relationship with non-biological constructs, props, and aids. So that's the type of idea. We're working on aesthetics, so it's not really to create a functional cyborgs, but to work really on the way things look. The interest is to create a different relationship. As I was saying, I think yesterday, where is it? When we think of the mobile object, there is a technology, but this object embeds a specific interface and the way we relate to it. So what we have here is an object which is basically a miniaturization of a laptop. There is a screen, you mainly interact through a keyboard and the visual input and output. And then you see things and then you use your hands. So it's fundamentally a laptop shrunk down. And it has a shape which we think is futuristic because it looks back like something from the 1960s. It's shiny, clean, perfect monolith, 2001 Space Odyssey with the monkeys jumping around and everything. Then you put it in your pocket and you go around and you take it out. And I would argue that this object has nothing to do with the human body. It works as an external sensor, like it's a new sense, like as a communication sense, is something that is altering the way your mind works, and then we can see it in our daily lives. It's really profound and clear, I think, to everyone. If we lose these objects, we feel lost, and then we interact with it at an incredible rate throughout the day, but this has nothing to do with the body. So what I'm interested in, there will be also the content of the activity that we do afterwards, is to try to rethink in a radical way a relationship with technology. I do think that the relationship that within the body and this object doesn't work, and what I'm trying to do and what I think is a design agenda which is worth to be pursued is to try to imagine an alternative. So I'm not interested here in developing a different technology for the mobile itself, but a different look, a different relationship with the human body, a completely different way to think of the object. So sometimes then you go through the things again and you rethink about them. So when we did this mask, we kept redoing the shooting over and over because there was this thing with the hair that was not working. Somehow the mask didn't really felt like being radical to the point it should be. And then sometimes you just need to simplify. So I'm quite happy. This is the first time I'm showing it. 4 years later, we had an idea of redoing the shooting in a more radical way. Take away the hair, that was the problem, and then pursue a more radical image. So I think that it's very important for me to go through again and again the projects which I did at the beginning a few years ago, and then rethink of them. In a way, I think that going back towards the origin of your creativity, the origin of your drive, what was that you wanted to do, and on is kind of discourse that having inside yourself is enriching your production. Also, this project triggered a number of conversations, and then that's probably the most interesting one. So we worked on this. We were actually engaged by Andrea Morgante of Shiro Studio to work on a walking stick. So the idea is that the walking stick is a product which has a very strong stigma. So people don't want to use it because that's a sign of disability. And I think one stream of research that we pursue and we're interested is to rethink disability and to think disability as a catalyst for possible change and transformation. I think that what is interesting about the discourse about prosthesis in contemporaneity is the fact that we can think of a trauma or a disability as an opportunity for something different, an opportunity for change. And there is an interest in trying to rethink the products which relate to disability. In this case, the walking stick. So the designer has this idea of the stick of an external bone. So the idea was that, okay, let's try to think of the stick as an external bone that we use, and it helps us to move and it gives support in a way. So as the bone, you know that the bone has outside, I'm quite fascinated by bones, which is something a bit weird to say maybe, but there is the fact that in terms of morphology, they have these super clean shapes outside, while inside you find this porosity, which is quite incredible. And generally, the densities of the pattern change according to the stresses which are applied to the bone. So in a way, it's an incredibly optimized object in itself with this incredible difference between the shape from the outside and the shape in the inside. And you don't know it until you cut it through. So we try to apply the same logic to the walking stick. From the outside, of course, it's more cultural than the bone, so the fillets are quite controlled. And the idea is to have a very clean shape outside. The shape is optimized for the way you handle it, and then for the way you can put it around. So it's an object that can stand on the handling. It can be put against a wall or against a table. And so in this way, it's hard for it to fall, and it engages in a different way with space. And that was the design of Andrea, and we worked mainly on the inside. So the idea was to apply then the pattern that we saw before with the mask to a volumetric condition. So this morphology is driven by a stress map onto the object, which we did with an engineer at Arup. And it's denser in the areas which there are more stresses and less dense in the areas in which there are less stresses. And then that's inside and you don't see it. It's 3D printed again. moving on, here we are at the point with this project. I'm going to show something that comes out of a research agenda, and for me, it's something work of the last year, and I still haven't post-processed it entirely, so it's something which I'm still exploring, like what Jamshid was saying before, that the creativity is this pool, and then there's the water, and then in a way here I think it's something which is time to discuss. And the project was developed at the Urban Morphogenesis Lab in London, where I teach. The lab is directed by Claudia Pasquero, and I teach with her. Every year we have a group of students, 13 to 15 Chinese students. They work, it's a master's degree, so they do a 1 year studio work with us. They do one project. And we are interested in general in the relationship between artificial, human, and biological intelligence in design, and how there are relationships between these things. You're not architects, so you may not know that, but there is a big discussion on computational design in architecture. At the moment, it has been in the last 15 years or so. The discussion is pretty, goes quite in depth on the relationship between human intelligence, artificial intelligence, in terms of the use of digital tools in design and computational procedures. It's a bit less on the side of biological intelligence. So our research is to try to think how to incorporate biological intelligence in design. And to do that, we are interested in investigating this idea of the biocomputer, in which a computer in its most fundamental concept is just, or an algorithm, is a procedure that takes some inputs, processes them, and gives an output. And then in this sense, we're interested in how we can relate a design context or transform, abstract a design model into a biological model that can then give information to a digital model. So how we can have a flow of information going from a design context to a biological model to a digital model. And then this, I know, is pretty abstract now, but we're going to get into details soon. So we work with spiders, Arachnocomputer, and with living spiders. And we started by doing these models, which is the basic idea of the biocomputer. So the model, we can describe it as a box into which the spider lives. And then structures, a lattice is designed, it's a 3D printed lattice is designed within the box. And that's the space into which the spider lives. The spider is being fed with crickets and water. And then in time, it spins its web. And what was most interesting to us, and that was the first finding of our experimentation, is then the spider spins its web in relationship with the structure. So different sizes of the base structure generate different type of shapes in the web. And then you can control, and maybe more than control, you can orient the way the spider spins its web through the morphology of the lattice. It's a very simple idea at the end. It theoretically can sound more complex, but the idea is that the spider connects to what it has, so it uses the existing structure as scaffolding for the web. And we were interested in building more and more complex models to see how the production of silk may change in time. So we were working on one side on this type of biological models. On the other side, we were working with digital model and digital simulation. We were exploring a digital algorithm which is named shortest walk, which is basically the simplest description of the algorithm. So you have a graph and you have a line, say I want to go from point A to point B, and then the algorithm is computing within the graph, between the network of lines, the shortest walk to move from point A to point B. And if the logic is very simple, you can apply it to way more and more complex scenarios and get drawings which are more and more complex. The idea is that each of the fibers within this drawing is controlled by that algorithm. And again, in the idea of the Arachnocomputer, we were interested in seeing how we can create a connection between the biological model and the digital model. So that's one project which I'm going to show. It's an architectural project in this case. So we are in Australia, and that's an abandoned warehouse. And we were attracted by that because in the project we try to relate to contemporary topics. Like in this case, there were a few articles saying these cities in Australia are haunted by spiders. Spiders are everywhere. Spiders are a problem. We don't know how to do with that and how to deal. And then we generally try to have an approach that goes away from problem solving to scenario envisioning, as we have discussed a few times already. So we started to try to think how spiders can instead be seen as a resource rather than a problem. So there are a few papers now which are studying the silk as material, the spider silk as material. So we started thinking that maybe thinking of a scenario in which we design a farming system for spider silk may be of interest. So that the work here in terms of brief of the project is to try to think how to convert this abandoned warehouse into a spider silk farm that is using the existing resourcing, the spiders, to harvest silk, which then can be used for a number of applications. How do you design this spider farm? Through an arachnocomputer. So the idea is that you start from the existing design context, the 3D model of the building, and then you somehow abstract it and approximate in the lattice of the biocomputer. So the first attempt that we did here, we took a part of the building, abstracted in a box and then to a lattice. And this is the diagram of the biological model that we work with. So a biological model with this lattice was created, and then the spider is placed inside, it starts spinning, it creates a web. In this case, quite a beautiful web. And then you do it again, different type of selection of the context. You abstract into a different type of lattice. You have the spider spin its web. And that's the basic formulation of the biocomputer. So we have the biological model. The distribution of the web is translated into a density map. Now, maybe it's not too clear, but the density of the dots changes in relationship to the densities of the silk. And then you use this data representation to inform this simulation. So the fibers are changing in density in relationship to changes in density in the web of the spider. So in this sense, the spider webs acts as input for an algorithm that is creating the design output. Again, in this case, we changed the extent of the biocomputer, taking the full structure, built a model, the spider spins a web, we extract a density map. In this case, also the trajectories were extracted. So these are the trajectories of the spider that it moved while creating the web. And then we use these trajectories to orient the digital simulation. So what is here, what we managed to achieve in this project is this flow of information from a biological model, a biological intelligence, which is the one of the spider, through a way to extract information out of that, trajectories and density maps, and eventually orient a digital drawing with this simulation. And this is the proposal of the spider silk farm. We are at the point in which the method is in place, the thing works, and to be honest with you, I don't know if this thing is relevant in any way for design or where it can lead. So I'm at the point in which you do something out of your drive for that, and you still have to think what that can be used for, how it can be negotiated with the world, how it can lead to a different type of experimentation, if it can open up other scenarios, and everything. So I'm more than happy to discuss it. If you have criticism, please go ahead. Any feedback now on that is mostly appreciated. Another mask. In this case, the algorithm is quite similar to the one used in the arachnocomputer, but applied in a different way. Here we were interested in fibrous morphologies again, but applied with different densities than from the very first masks. So how can you think of a fibrous morphologies in terms of a tissue. So a tissue that changes in density or in orientation of the fibers rather than controlling the single shape of the individual fiber. I'm working on an image. And that's another PostNatural Cyborg. The logic I described before of the shortest walk was applied in this project, still from Zaha. And then it's a collaboration between Zaha Hadid architects and Dilomas, who is an artist, Max Cooper, the DJ, and other people. And in this case, this is a projection mapping. And then we had to basically do a 10-minute projection mapping onto the castle of Karlsruhe. The castle of Karlsruhe has this 180-meter-long facade. And so the idea was to apply a similar algorithm, at least to certain parts of the video, to animate the facade. I find it interesting because in a way it's pretty similar to some of the things that we saw before. Like there is this relationship between morphology and substrate, which is also in the biological models of the Arachnocomputer, in that here, instead of having a spider that spins a web in relationship to a 3D printed substrate, there is a digital entity growing on top of the facade of the building, and it relates to specific features. So in a way, again, you abstract a model and you have the simulation working according to it. And we are at the end. So what I hope I showed, what I was trying to show is how you can, it's a proposal for a design research agenda in which you move from something that comes out of kind of pure drive, pure creative drive, and then in time it gets structured more and more. And I'm absolutely in favor of speculation, absolutely in favor of an artistic approach to certain part of your work. I reject the idea that as a creative you should look only for market application straight away. I think what is interesting is when you can work at multiple levels and then engage in different levels of negotiation and have quite a portfolio of projects that go in different directions. Thank you for your attention.